So welcome back here. Before we will hear and see another thrilling presentation, this time from Martin Seidenberg, I already see him in the room. Please join us next to see a product innovation video from the FIGHT group and from Tokai Thermo Interlining from Japan. And then we will be right back. Thank you for watching.
Hello everyone. Remember, not too long ago it was very simple to produce shirts because shirts had more or less the same style over a long period of time. The only differentiation was probably the type of the color. Then suddenly we have slimline shirts. We have all types of different difficult fabric, and those presses like our HPV or Twin Star press, where we could use the same machine day in, day out for high quantities of the same type of shirt, were no longer really suitable for those modern type of shirts. So we had to develop a new type of machine. And we found out that for these new fabrics, finishing, meaning pressing the garment from inside out with steam and air, while we are controlling the sizes and the shape very delicately, is the better method. So we developed a machine with adjustable sleeve tensioners, adjustable in the angle and adjustable in the height. And we also made sure that during the cycle of this machine, we don't interfere with the already pressed cuff and the already pressed color by the design of the machine. So now, this machine we can use for all types of different shapes from the different brands. And we stay inside the specs with the sizing, no matter how flexible the material is, if it's jersey or if it's stretch material. We can stay in the size and we can finish all sizes on one machine with very little adjustment time. And the best thing is the productivity. We can do one shirt in 30 to 60 seconds, depending on the material we have, including the total finish of the sleeve. So, while in the past people chose specialized machines for the same type of garment in huge quantities to do the job, nowadays we need flexible machines which can do the small production runs we have today with very delicate materials. And therefore, we recommend our shirt finisher SF26. Thank you very much.
Tokai Thermo, established as a hair interlining manufacturer in Gifu, Japan in 1958 with the response of customers first and the strength of development capability based on the challenging spirit.
I think I got some trouble.
The turning point came around the second generation president, Mr. Shigeo Asano, who started fusible interlining production. And the company launched our own brand, Thermofix. After that, while increasing the product variation of fusible interlining, responding to the evolution of apparel industry, we also developed an approach to find new applications and possibilities in the adhesive technologies that we have cultivated as our own. In addition, we have responded promptly to the rapidly advancing globalization and have also expanded widely overseas. Tokai Thermo always follows customers' needs faster and better than anywhere else. Passion for challenging new business is our basic DNA.
Dear IACD friends, we Tokai Thermo desire every member in our association would be healthy and safety in such a terrible circumstance. Although we are very sorry we could not meet in supposed Bucharest Convention this year, we believe every designer must work harder for upcoming recovered stage. We Tokai-san also continuing to develop new technologies at that time. We expect we will be able to meet each other again in next convention, maybe next year. Thank you very much and take care.
Okay, thank you very much, Mr. Veit, and thank you very much, Mr. Asano-san, for your warm words and for your personal greetings. So now I would like to introduce our next speaker to you. It's this time Martin Seidenberg. He earned several degrees in mechanical engineering and in plastic and textile engineering. Currently, he's actually pursuing a doctorate at the Institute of Textile Technology in Aachen. And his motivation is to establish a new and efficient production technologies for ready-made garments and for smart textiles. And as such, he will present to us his ideas of microfactories and of production on demand. So welcome, Martin Seidenberg.
So thank you very much again for having me. I'm very sorry for that technical issue. I was saying I want to thank Ms. Schöning for the organization of this event. It's been a pleasure working with all of you. And while I think that this is a very good thing, I hope that the next time around, this time next year, we can all be in a nice city and meet each other in person and do a little more and then just share our screens and some presentations. But for now, this is the best that we can do, and I think this is a great way of still working and doing stuff while during this crisis. So. Oh, this is from the top. That's not good. Let's go back to that slide. Okay. All right. Okay. So in the second part of our presentation, I think we can regard it as one larger presentation focusing on the topic of fashion demand and the problems that our industry is facing today. I have to hide that. I want to focus on the technologies behind what David described as ideas and what he touched on with things like modularization. So I want to focus on two things here: modularization as a concept and how we approached it in the past and what we think works, and agile manufacturing technologies and what that really means for, let's say, microfactories and as well as for traditional manufacturing plants. So product modularization, David touched on briefly, is a concept that we use to make complex products easier to produce in smaller quantities of each design. So when we look at dresses, for example, we analyzed around 500 styles of dresses from 3 major online platforms, and we discovered that these dresses can, with some effort, be transferred into a modular system. And what that can mean for a supplier is that actually things become simpler. So we can, as David mentioned, make contracts with a supplier for the supply of 10,000 dresses with a style in each of these 5 brackets, and then the individual pieces don't change so much. When we, for example, change the print, when we change little details, the overall piece is still pretty similar. And so it becomes much better to handle. So we can standardize our production steps, and we can produce smaller quantities with ease and in a cost-effective manner. We analyzed several of these simplification steps, and we found that further cost reductions can be made if we automate certain processes. For example, and you will all know this, the largest and the highest cost point is sewing. And we found that when we use this, when we use automation and we use modularization in combination, we can save around 17% of total costs. And key technologies here are definitely automatic sewing, where we haven't seen a breakthrough in the last years. I think many of us were thinking that with startups like software automation coming up, that we were going to see breakthroughs. We haven't actually seen those really hit the market, but we are continuing to invest in this field, or we're continuing to do research in this field. And we think that in the future, there's going to be some very exciting things coming up in the area of automated sewing. So we can see that if we reduce the manual working time of a dress by 39%, we can achieve high savings depending on where we make that garment. And what that means for our production is that our production can move closer to our markets. So you can see, for example, that there will be a cost saving of $2.5 per dress if we move production from a developing country, or from a country in Southeast Asia to a country like the US. And what that in turn means for the location of our production is that we can produce closer to our key markets. And when we do that, we're quicker, we have a better relation to our suppliers, and we can more quickly change our orders as the market develops. So you can see that just by applying this modularization technique to dresses, we can cover a huge variety of designs with making very small modifications. And we can thereby cut delivery times and make producing closer to our key markets financially viable. The second part, and what I want to talk about, is agile manufacturing. And the first example of our agile manufacturing, or first case study I give you, is heavily influenced by what we just talked about in terms of modularization. And that is actually the sustainable mass customization of jeans. You all know that that the main separator in the variety of jeans is actually the kind of wash that is applied to it, and the abrasive features that are put upon a jeans during manufacturing. And in the last years, we've seen new players like Genealogia and Tonello hit the market with laser systems and making this customization a very, very quick digital process. And if you set up the entire finishing part of your jeans production in this digital manner, and also optimize the washing processes, you can come up with a very efficient, almost made-to-order or almost fashion-on-demand kind of production, where you can easily handle small batches of varieties of washes and fades to your jeans. So if we look, for example, at the catalog of nudies, in this case, we have 9 cuts of jeans, we have 28 different washes, and that alone produces 220 jeans varieties. And what we then did was so this digital technologies enable this batch size one production, as we call it. So imagine going on a website, specifying the cut of jeans you want, the kind of fade that you would like, that becomes an order, and we went out and set up the factory that can cover this kind of complexity in production. So yeah, this is also further enhanced by the washing processes that are applied afterwards. Here there's a lot of advancements to be made in terms of how much water can be saved. And actually, when we went and did this with a customer in North Africa, we were able to save up to 90% of water per jeans. So we got the total water consumption of one jeans down to about 1 liter per garment. And again, as with modularization, the standardization and digitalization of these process steps brings further advancement or further cost reductions, and we can again move our production closer to our key markets and become quicker in selling our product. So this is actual footage from the time we were at our client in North Africa when we designed the new factory, and where we used design thinking methods. We used workshops to come up with the planned layout, actually also involving the workers, which in our eyes is a key to successful production. As also David mentions, that machine designs should adapt to the worker, not the other way around, and challenging established ways of doing things is the way of doing it better. So changing how washing machines loaded, changing how laser machines are being operated is key to being successful. Yeah, and the factory that we came up with is not a big factory. So this is actually a showcase designed to produce around 4,000 jeans per day, and we split it up in several zones. So we have one zone that is mainly the laser processing, where we have single batch processing. So each jeans is handled individually, and each jeans can be treated individually with any sort of laser pattern design that you want. You could also think about having laser patterns that are user designed or are enabled or changed depending on how the user is built, how the customer's legs are shaped. And moving on from this zone, we go into a small batch processing zone. Usually we think in terms of 60 genes per batch. And here we group the genes that have been treated with on the laser into batches of 60 that are supposed to follow the same washing process. And then we can officially move them through this washing process. And afterwards, we end up with completely different genes. They will all be individual depending on how the laser structured them and how the washing cycles were applied. And that just gives us great variety while also being able to handle the complexity. So we can see that by using digital technologies, which are changing the entire landscape of fashion technology, and modern washing technologies, we can not only reduce the complexity in producing individualized jeans, but we can also greatly improve the sustainability of our product. So further agile manufacturing techniques that I want to touch on, in this case, are producing in store. So taking your production of garments and moving it not only closer to your key market, but actually right into your key market. And this could be something that is super interesting for clothing stores, which may be struggling in this crisis, which maybe have to reinvent themselves in a bit to in the future compete with online markets and maybe global players. So this is a case study we did with Adidas in Berlin several years back. So it was the Knit for You project. You might be familiar with this. We set up a concept store. People would walk in. They would create an avatar with their size and shape. They would then enter a virtual augmented reality design process where they could change shapes on their shirt as they wished. When they were happy with their design, they would press print, and the machine would be flat knitted, thermoset, and finally finished manually by a shop employee. And about 4 hours later, the customer can take home their garment. So, and this entire process chain was done within the store, right in the center of Berlin. So it showed that this can be done. It only ran for 3 months, sadly. It wasn't meant to be a permanent feature, but I think it paved the way in some sort of for a concept like this to one day enter the market. And we are actually right now working with customers of other big brands to bring concepts like this to the store, to the market. Adidas Knit for You, as the name suggests, focuses on knitted garment, ready-made knitted garments. We are actually doing this right now for the cut and sew way of making garments. So for t-shirts, we are setting up a store factory like this that is hopefully, if everything goes well and COVID-19 doesn't interfere too much, live within this year. And then it's my pleasure to show you this example for a local and custom micro factory, because Mrs. Yvonne Heidenbode is here, and she was a great partner in this project, which we realized within 4 months. at the beginning of 2019. So this was the Smart Textiles Microfactory that was shown at the Text Process last year. And here we wanted to show that not only ready-made garments and clothing can be made digitally and in a quick and effective manner in microfactories, but also this would be possible for smart textiles, which are a very new class of products. We do a lot of research on them. And what we see is that there's a bunch of prototypes around all over the world. Everybody has the greatest prototypes when it comes to smart textiles, and they can do the craziest things, from measuring your body signals to communication devices. Nearly everything is possible. Integrated lighting, of course. But what nobody really shows is that they can produce these at a scale. So I can see all these prototypes online and everywhere, but I can never really buy them, with the exception of a more or less successful jacket that a major internet company put out several years back. So we wanted to challenge the idea that smart textiles weren't really producible on scale, and we wanted to do it in front of a live audience at that fair, and that was the Smart Textiles Microfactory at Text Process last year. And we had a design that was predetermined. We had embroidery process on the floor. We had cutting, and then we had an automated sewing process by a machine partner in Vitron, which is very interesting. And now you're seeing all these case studies, and you may be thinking, okay, so where do I start? If I want something like this, how do I enter this field? How do I participate in this new exciting field of microfactories and producing on demand? And we are also seeing companies not only from the textiles manufacturing business or from clothing manufacturing, but from all over the textile industry and even from other industries who are saying, we hear every day about Industry 4.0 and that we got to invest in digitalization and we got to invest in augmented reality and artificial intelligence. But what is it actually? What does it mean, Industry 4.0, and what does it mean for my business, and how can I be a part of that? And for these companies, we set up the Digital Capability Center, which you can see pictured here. And it's a full-on production of, in this case, wristbands, smart wristbands, which have electronic features integrated, and which can be produced in this factory line entirely on demand and entirely customized to the user specifications. So we actually start with a warping process. There's a narrow band weaving machine in the line. We thermoset the bands, we coat them, and make them ready for printing. At the part of the printing, actually, we start with the customization of the wristbands. So the user can specify the length, the color, his name, if he wants it printed on the wristband. And then we cut the wristband, we sew it in a very modern and very ergonomic sewing station, and it's finally inspected and handed over to the customer at the end of the line. And it doesn't only serve as a production facility for wristbands, because that's not really a viable business for us, but really it's a digital and it's an Industry 4.0 classroom. And along this process chain, we have an insane number of showcases for Industry 4.0 and for digitalization technologies. So I'm not expecting you to read all of this. It's really just overwhelming, and you have to experience in person. And I hope you can, as soon as COVID-19 ends, come and visit our demonstration factory and see for yourself. But we group these in four large areas. So we have, for example, the digital enabled management. That is, for example, the use of large screens and the use of sensors that, upon touching, will display information about how the machine is running. And this is, for example, important for plant managers who can, with one glance, see what's happening in my line. And also behind it, there's an artificial intelligence that will showcase problems and highlight where the line might not be perfectly running at the moment. Then we have the advanced analytics, which plays into this, but focuses more on the quality issue side. So by reading out various data from the machines that are already there, like the energy consumption, the moisture in the air, the temperature of the machine, all of these kind of things, which you really don't have to change your machine for, but you just have to use sensors which can collect the data that you're already generating. We can use these for quality engineering, and we can see where are the problems in our line. Like on Mondays, we always have bent printing results because as it was just the weekend that was over, the temperature in our factory is higher. So it's simple stuff like that that can make a huge difference. And then we have the digital ways of working. So that means we have augmented reality for picking and for logistics. We have autonomous vehicles going around and helping our workers. And finally, we have advanced automation that, the AGV would be another example of that can automatically restock shelves and so assist our people in our working line. So I hope that that all of you can come back and to Aachen and see and experience this for yourselves. I think it's very, very cool, and you might not even need to be from the textile sector to find something in this that will work for your industry, which I think is the greatest thing about it. So this is basically your universal appeal. If you want to check it out, it's if you can go to dcc-aachen.com and you can check out the line virtually. You can walk through it and see all these showcases for yourself. And so these are three showcases that I wanted to present to you of what we've done in terms of bringing the textile industry and bringing frozen manufacturing towards an industry 4.0 age. But of course, there are several designs, several solutions still missing. And as David touched upon earlier, and as also as Mrs. Hein-Baudet questioned, machine design has to change, especially sewing machine design hasn't really changed all that much over the last years, and we're still seeing foot-operated machines that are okay for these huge or for these long linear production facilities. But if you want to make products agile, like in small groups, and if you want to work is to engage with the product, we have to change the sewing machine process to a more interactive design, maybe not foot operated, so you can operate better while standing, and further integrate the user into the experience, and use the data that we have, use the knowledge of our product. We know the length of a seam, we know the stitch lengths that we want, so we can maybe set the speed of the machine digitally and not give that control to the operator, but really have it determined for what's best for quality. Then we want to actually implement a demonstration factory that is completely set up for agile fashion production. So what we have here with the DCC that I just showed you, that is more for the textile industry as such. We start with warping and we finish with a little bit of sewing, but we want something that is really, that brings the cut and sew process to a place where people can grasp what the future of fashion production can actually be, and can actually be for Europe and for Germany. So we want to set up a demonstration factory, ideally somewhere where fashion is happening, so maybe in Berlin, and we want people to come and experience and work with us on changing the way that fashion is being created now and in the future. And lastly, Lola mentioned it in her presentation to start this convention. So digital platform technologies are changing our life on all fronts, and we see the emergence of many platforms on the web that try and solve smaller problems that exist between suppliers and brands. But we think it's important to integrate all of these players even more by bringing them together on platforms. So machine technology providers, brands, suppliers, textile manufacturers, they all need to be connected to make this whole thing work. So now I hope you got an idea of what we think the future of the fashion industry should look like. I think there should be some bullet points here. Yes, there are. So we want to make fashion on demand work by using modularization of our products to keep the simplicity down, or bring the simplicity down, while also still being able to make very interesting and changing products. We want flexibilization, like I showed you with the laser technology, so that we can increase again the design features on our products while having the complexity low. We want to showcase and raise awareness for all of these available technologies, as well as future technologies with our DCC here in Aachen that showcases Industry 4.0 technologies, as well as a custom or specifically designed fashion production showcase, if you will, in Berlin. And we want to provide training for the for you, if you wish, for the textile industry, for the clothing supplies industry. I think we can learn a lot from you, working with you. We are classically mechanical engineers by training, and we have a sometimes very weird way of seeing things. But I think you can also learn from us and how we approach problems and how we try and tackle problems that exist maybe in the clothing industry with principles that we maybe learned from the technical textiles industry and from the machine development that we did over the last 50 years or so. So yeah, now I touched upon that already, but I'm very sorry. So yeah, which solutions are still missing? I just explained that to you, and with that I want to close my presentation. Oh, I have a special announcement actually. Before I let you ask your questions, I want to bring your attention to something we did just last week, or over the last 3 weeks. A platform actually that David set up over long nights of working from home and working with colleagues all over the world. We made a platform called neatmask.com, and it brings together buyers and suppliers of personal protective clothing. So on the platform, all you have to do if you're a supplier of personal protective equipment is make an account, specify what products you can sell at what price and in what quantities, and then people who will need masks, they can go on the website, they can check out the they can check out the listings there, and they can find a supplier that's right for them, and hopefully get personal protective equipment when they really need it, so that this crisis doesn't get any worse than it already is. So if you know anybody, or if you're willing or able to help yourself, it would be a pleasure for us to work with you and help bring protective equipment to the people that really need it. So with that, I want to close, and I'm happy to answer any questions.
Okay, thank you very much. Thank you very much, Martin Seidenberg. Thank you also for your kind invitation, and you better watch out, because it could be that someday we are all turning up in Aachen with a whole bunch of people, and we are a lot, believe me. So
yeah, as long as we keep 2 meters of distance, it's no problem.
Okay, wonderful. Wonderful. Oh, yeah.
No, but seriously, please do, and we'd be happy to host you and be happy to show you around. There's lots of interesting things here in Aachen and the RWTH, as well as other research institutes, and I think yeah, that could be a really cool trip for us.
Yeah, we will do, I promise. Okay, so thank you again for explaining to us the automation of the standardized production steps, and also for showing us how our new model factories are working. As you know, most of our attendees are pattern designers, pattern makers, and product developers. So I think an interesting question could maybe be, how does the production in microfactories change the product design process? Can you tell us a little bit about that? Yeah, of course. That is a very interesting problem that we are also facing right now. As I mentioned, we are designing another microfactory, or a store factory, if you wish, for a client that he wants to set up one of his flagship stores, but he doesn't want to make flat knitted sweatshirts. He wants to make T-shirts that are sewn. So to do that efficiently and to do it on the scale that he wants to do it, he wants to involve some sort of automation, and also you want to involve automation to make it interesting for the customers. They walk into the store, they can say, oh, I got this shirt from the store that uses robot technology to be sewn together. But as you can imagine, this brings a lot of challenges in the product design process with it, because the standard seams that are present on a T-shirt today, especially in the area of the shoulders, they cannot be handled by any robots that I'm aware of in a functioning way.
I mean, there have been concepts. Software automation has tried and done that, but we haven't seen it come to market. And so we had to we tackled that problem by not only going into the machine design and try and come up with an automation solution that could do this, but we also said, okay, the product has to change. If I want to make it automated, if I want to make it in a store factory, in a micro factory or whatever, the product is up for this debate and for discussion. And of course, designers will, I mean, they're always restricted by what can be done in production. So that's not a change for them. So I think pattern designers will find that they will have this, they will have a new set of tools that they can use, and they have a new maybe palette of themes that they can create to design products. So in one way it's limiting, but in another way it can also be really interesting, and it can create a whole different kind of garment that will be sort of the garment of the future and can be made automatically. I hope that didn't go into detail too much.
Yeah, no, thank you very much. We have a question from Dragan from the US. He's asking regarding the situation of PPE production, will next season's demand of standard garments decrease? And if so, to what extent, do you think?
Excuse me, I didn't get the first part of the question. Regarding what?
The situation, regarding the situation of PPE.
Okay.
Will next season decrease?
I mean, we're seeing a decline in asking for regular garments or clothing at the moment, and because they're at home, they're not going out, so they're shopping less. So I think that alone might influence what's happening next year in the clothing market. It's hard to say whether from a machine side or from a production side, this whole production of PPE equipment will influence the clothing market. I don't want to dare and suggest maybe a little bit.
Yeah. Okay. And Bruce is asking a question. Turnover is usually driver of the business, as long as wages are cheaper than machines, and the customer is not willed to pay more. How shall this challenge be solved?
That is a good point. Definitely. However, I think we're seeing a bit of a changing landscape here as well. Turnover is the driver, absolutely, but customers are also changing. They're asking for more customized clothing. They're asking to be a part of the process, and they want products that are sustainably made. So there's a growing market for sustainably made products and also for products that are made locally. And I think we can tap into that and go with our micro factories or our nearshoring into the segments of the clothing market that want sustainable products, that want something that is made locally, and where they can be part of the process, where they can engage with the product, design it, make it their own. And then I think they're willing to pay more for it, and they're willing to pay the price. Yeah. Another angle that maybe is interesting, I think, if we view it as a way of reducing waste in the textile industry, we could argue that if we bring waste down by 20%, we automatically can be a little bit more expensive on the production side. But if this guarantees that the product will meet the demands of a customer, will fit, and will be sold more easily than a standard product.
Okay, thank you very much, Martin, again for your presentation. So, and I would like to conclude now by saying thank you to all speakers for their enriching and inspiring insights in our convention topic, which was shifting paradigms and emerging challenges, and I would add also opportunities. You will all receive a record of this event, same as our friends in Japan, by the way, and the contact data of our speakers in the next newsletter. Thank you for joining us today. It feels good to stay connected, and even if we cannot see us face to face, but we will hopefully next year. Thanks again to you, to our partners, for your videos and for your support in this first virtual event of IACDE International. Let's stay all together thoughtful, confident, and optimistic. Take care. Have a nice rest of the afternoon. Have a nice weekend and goodbye.